Good morning. We have gone through our basic understanding on IC engine. IC engine will have one piston, will have crank, will have crankcase, will have exhaust port, inlet port, compression system, flywheel, cam. So many things we have discussed. Now we should solve some problems so that we will understand how thermodynamics is happening in the IC engine and we are getting power. Fuel will be burned and it will be giving heat energy. That energy will be converted into your torque on the shaft. So we discussed two type of engine, Otto cycle and diesel cycle. So Otto cycle will have constant volume heat addition process 1, 2, 3, 4, and diesel cycle will have my constant pressure heat addition process. Other processes are almost same. Okay, PV PV. Now another cycle also there called dual cycle. So people thought like say take two-stroke benefit, take four-stroke benefit and make another cycle called dual cycle. Dual cycle is like this. Some portion will be constant volume heat addition process, some will be constant pressure heat addition process, then you get expansion. Okay, so 1, 2, 3, 4, 5. So 2, 3, 4, that part is different. This is called dual cycle. This is called Otto cycle. Otto cycle already written. So this is dual cycle. Fluid will be compression will be happening, expansion will be happening. So we are getting power PV per gamma equals constant. Here also PV per gamma equals constant. There also same thing happening. PV per gamma equals constant. Here also PV per gamma equals constant. Now through the problem we'll try to solve this problem, like what is the temperature, pressure, different point, what is the efficiency, and different other parameter also try to calculate. Let's try to solve for two-stroke engine or spark ignition engine. One spark ignition engine has or Otto cycle, Otto cycle has compression ratio 10. So many books they are writing RK, many books are writing R, many books have written CR also. So just in this problem I have used the term CR, means compression ratio of 10. It operates with a low temperature, so that means first I have to draw my PV diagram. Okay, so draw the PV diagram. This is curved line, this is curved line. 1, 2, 3, 4. SI engine compression ratio is 10, so that means V1 by V2 equals 10. Operates with a low temperature 200 degrees. So T1 equals 200 degrees centigrade, and low pressure P1 equals 200 kPa, kilopascal. Work output is given, W output put 1000 kJ per kg. Kg per kg means per kg of air or mass. Calculate the thermal efficiency. So we have to calculate eta thermal, eta Carnot. Okay, given data Cv equals 0.717, gamma value also given. So using this one we have to solve. So first we have to see this temperature is given in centigrade. So all the calculation will be done using Kelvin scale. Okay, so T1 will be then 473 K, 200 plus 273. Now thermal efficiency eta thermal equals 1 minus 1 by gamma R per gamma minus 1, CR or R. Okay, so 1 minus 1 by 10 gamma minus 1. So it is gamma means 1.4. So the value will be coming 0.0602 or 60.2%. Okay, directly this formula is discussed was discussed in previous lecture. So now process 1 to 2, this is isentropic process. Isentropic process means PV per gamma equals constant. Now T2 by T1 equals V1 by V2 gamma minus 1. Okay, therefore T2 equals 4 T1. T1 is 473 and V1 by V2, you see V1 by V2 is compression ratio Okay, it is 10. Gamma means 1.4 minus 1. This value is coming 1188 K. Okay, so W net work output equals W1 to 2 process compression work plus W3 to 4 process. Okay, now 1 to 2 process CV T1 minus T2 plus T3 minus T4. We are assuming CV is constant. Okay, now this value will be giving like this: 1000 equals 0.717. T1 is given 473 minus 1188, we got plus T3 minus T4. Okay, now T3 by T4 equals V3 by V4 by V3 gamma minus 1. So this will be giving T3 equals T4 10 0.4 equals 2.512 T4. Okay, so we got this T4. Now if I put numbering 1 and 2, now 1 and 2 gives, what will it give? 1000 divided by 0.717 plus 1188 minus 478 equals 2.512 T4 minus T4. So this will give T4 equals 1395 K. So now therefore T3 equals 2.512 T4 implies T3 equals 3505 K. Okay, now eta Carnot equals 1 minus T low minus T high. Okay, 1 minus T low means 473 minus divided by T high 3508 3505, so 86.5%. Now we'll go to another problem, similar Otto cycle problem. Here again, then PV you draw 1 2 3 4. Okay, there will be many IC engine books, so student can follow the any IC engine book. So I'm using the Rajput book, so they are in that book also. There are lots of example problems are there, student can solve. Okay, so an engine working on the Otto cycle, inlet air pressure is given, P1 is given 0.1 MPa equals 100 kPa. Okay, and inlet temperature also given, T1 equals 35 degrees centigrade equals 35 plus 273 equals 308 Kelvin, and the compression ratio is given V1 by V2 equals 8. Now heat supplied Q2 to 3, heat supplied 2100 kJ per kg of mass flow rate through the system. R value is given 0.287, Cp value also given, Cv value also given. We have to calculate maximum pressure, that's P3, and temperature, maximum pressure and temperature. So T3 we have to calculate. Cycle efficiency, eta thermal efficiency you have to calculate. Mean effective pressure, we have one formula, we'll see. So P1 is 100 kilonewton, so Q1 also given 2000, so P2 by P1 equals V1 by V2 divided by gamma equals 8 by 1.4. Therefore P2 equals P1 into 8 1.4. Okay, so this this value is giving 1837.917 kilo Newton per meter square. So kPa or kilonewton per meter square. Okay, T2 by T1 equals V1 by V2 equals 8 power 0.8. Therefore, T2 is coming 707.59 K. Now, P2 V2 by T2 equals P1 V1 by T1 equals P3 implies P3 equals T2 by T3 by T2 P2. Okay, now Q equals CV T3 minus T2 equals implies T3 equals 2100 CV plus T2. Okay, so now okay, CV so it is coming like 3632.39 K, 39 K. Okay, now P3 T3 by T2 P2 equals 9434.8 kilo Newton per meter square. Now process 3 to 4. T3 by T4 equals V4 by V3 power gamma minus 1 equals 8 0.4 implies T4 equals T3 8 power 0.4 equals 1581.9 K, because T3 value already known, T3 value is already calculated here, T3 is coming from here. Okay, now Otto cycle or thermal efficiency equals 1 minus 1 by R gamma minus 1, pressure ratio gamma minus 1 by 8 0.4 equals 0.5647. So V1 equals RT1 by P1 equals 0.287 into 308 divided by 100 equals 0.884 equals 0.884 meter cube per kg. Okay, this is the specific volume. This is specific volume. Okay, now mean effective pressure, mean effective pressure MEP equals W net, how much power we are getting, and divide by specific volume V1 minus V2. So now W net equals Q in minus Q out. So 2100 minus CV T4 minus T1. You see PV diagram, PV it is like this 1 2 3 4. So 4 and 1, this one hit exhaust, so CV T4 minus T1. Now this value will be coming as 1185.922 kJ per kg. Okay, so therefore MEP equals 1185.922 divided by 0.884 minus 0.884 divided by compression ratio, that is 8. So this is giving 1533 kilonewton per meter square. So this is your answer. Now we'll go to another problem called diesel cycle. So here in standard diesel cycle, when you are talking about diesel cycle, first you draw PV diagram. Okay, then it is horizontal, combustion, and other points you connect 1 2 3 4. Okay, and air standard diesel cycle has compression ratio 16. So R equals V1 by V2 equals 16. At the beginning of isentropic compression, the temperature is T1 is 15 degrees centigrade equals 280 273 plus 15 equals 288 K. Now pressure also given 0.1 MPa equals 100 kilonewton per meter square. Now heat is added until the temperature at the end of the constant pressure process is 1480 degrees centigrade. Okay, this is 1480 degrees centigrade. Cp given. Okay, calculate cutoff ratio. Cutoff ratio means V3 by V2 equals Rc. Now cycle efficiency. Cycle efficiency eta equals 1 minus Q2 by Q1. Heat rejection divided by heat addition. So 1 minus 343.2 divided by 884.4 equals 0.62 or 61.2%. So it can be obtained from other equation also, like eta cycle formula. So let's ignore that one. W net equals Q1 into eta cycle. Okay, so W net means net work output will be lower than whatever heat input you have given. So that's why multiplied by efficiency. So 884.4 into 0.612. So it is coming 541.3 kJ per kg. Now V1 RT1 by P1 equals 0.287 into 288 divided by 100. So it is giving 0.827 meter cube per kg. V2 equals V1 by R. R means compression ratio, 0.827 divided by compression ratio 16. So it is coming 0.052 meter cube per kg. Okay, now V1 minus V2 equals 0.827 minus 0.052 equals 0.775 meter cube per kg. So mean effective pressure MEP is W net divided by V1 minus V2 equals 0.541, 0.775 equals 698.45 kPa. This is your answer. Now dual cycle. Dual cycle I already told that Otto cycle and diesel cycle both you mix and you make another cycle called dual cycle. So PV diagram. So constant pressure you divide into two, constant pressure and constant volume, and you make the cycle 1, 2, 3, 4. So some portion constant volume process, some portion constant pressure process. Then other portion, other processes same. They call dual cycle. Okay, if I draw TS diagram, it will be like this. Okay, vertical, 1, 2, 3, 4, 5. Okay, 2 to 3, 3 to 4, heat addition happening. So that's why 2 to 3, 3 to 4. So heat supplied two to 3 equals CV T3 minus T2 Q3 4 3 to 4 heat supplied CP constant pressure process T4 minus T3. Okay, heat rejected heat Q5 to 1. So 5 4 5 5 to 1 CV T5 minus T1. Okay, now eta heat work done by heat supplied. So that formula we will use later. Let's see first one problem on dual cycle. So in an engine working on dual cycle, okay, so PV one, 2, 3, 4, 5. Okay, so in working dual cycle, temperature and pressure at the beginning. So T1 is given 90, P1 is 1 bar. Okay, now compression ratio is given R is given V1 by V2 is 9, maximum pressure limited to 68 bar. So P3 equals P4 equals 68. The total heat supplied cycle. So Q2 to 3 plus Q3 to 4 equals 1750 kJ per kg. Specific heat ratio given, CV given, CP given. Okay. Assume kinetic and potential energy change is negligible. Air is an ideal gas, constant specific heats. Okay. So gamma is given 1.4, T1 is given 90. So it will be like 273. So 363 K. P1 1 bar, RK 9, Q1 is given, P3 given. Okay. Now 1 2 2 process. P2 by P1 V1 by V2 per gamma implies P2 equals 1 into R divided by gamma equals 1 9 power 1.4 is coming 21.67 bar. Okay, so T2 T1 V1 by V2 gamma minus 1. So T1 means temperature is given 363, V1 by V2 is given, pressure ratio 9 by 0.4. So this is giving T2 value 874. Okay, now process 2 to 2. Process, this is process 2, process 2 to 3. So P2 by T2 equals P3 by T3. V is constant, so V is cancelled out already. PV by T equals constant. Okay, so T3 is giving T2 P3 by P2 equals 8741.1 68 divided by 21.67 equals 2742.9 K. Okay. So heat added at constant volume. Again, I have to draw the PV 1, 2, 3, 4, 5. So heat added at constant volume process means 2 to 3. Q 2 to 3 equals CV T3 minus T2 equals 0.71 2742.9 minus 874 equals 1326.8 kJ per kg. Q23 plus Q34 equals Q total heat input. So Q34 equals total heat input 1750 given minus 1326 we got already 0.8 kJ per kg. Okay. So this would be giving 423.2 kJ per kg. Now CV equals 8. CV T4 minus T3 equals 423.2. So CV value is 1 is given there in the problem. You see CP value is given 1, CV is 0.717. Not CV, this is CP. So CP value is 1 given, so 423. So whatever data is given, you use that same data, you do not use another data, otherwise there will be error in result. Okay, so 1 T4 minus 2742.9 equals 423.2. So this is giving T4 equals 3166 K. Okay, for constant pressure process 3 to 4 process, cutoff ratio RC equals V4 by V3 equals T4 by T3 equals 31662742.9 equals 1.15. Now process 4 to 5. V5 by V4 equals V5 by V2, V2 by V4 equals V1 by V2 into V3 by V4 equals RK by RC. Okay. Now P4 V4 per gamma equals P5 V5 per gamma. Okay, therefore P5 equals V4 V5 P4 equals 68 RC by RK per gamma equals 68 into 1.15 divided by 9 1.4 equals 3.81 bar. Now T5 by T4, T5 by T4 equals V4 by V5 gamma minus 1 equals RC RK gamma minus 1 equals 1.15 by 9 0.4 plus 0.439. Now T5 equals T4 0.439 equals 3166 into 0.439 equals 1389.8 K. So Q out output here or exhaust heat, CV constant volume process. Okay, 1 2 3 4 5 PV. So for T5 minus T1 this constant volume process, so it's giving 0.71 1389.8 minus 363 equals 729 kJ per kg. Okay, so eta air standard efficiency 1 minus Q out divided by Q in equals 1750 minus 729 by 1750. So this is giving 58.34%. So this is the solution. Okay, thank you very much for watching this lecture of IC engine. Next day we will start next topic. Thank you very much.